Hello everyone, I am Abhijit Titarmare, Assistant Professor Electronics and Telecommunication Engineering Department, GH Raisoni College of Engineering, Nagpur. Today our topic is microcontroller. So before starting with microcontroller, we will see the difference between microprocessor and microcontroller. Okay, then microprocessor is a stand-alone unit which will process whatever input it will get, it will process it. And it will not contain any memory blocks or timer blocks or serial controller blocks. But where in microcontrollers it will contains all memory blocks plus all other peripherals in same block. We will see it by a block diagram. This is block CPU block. CPU block function is it will process the input, and connected to this CPU block there is RAM, ROM, serial communication and other peripherals. It is the case with the microprocessor, but where is the case in the case of microcontroller, all the blocks, these RAM, ROM and serial communication blocks are on the same chip, like this. The microcontroller contains CPU on same chip, RAM, ROM, random memory, then serial communication and timer blocks. When all these blocks are combined on a single chip, then it is called as microcontroller. Now we will see various types of controllers available in markets. Then we mainly classify microcontrollers in 5 different categories. These categories are depending upon various functions, like either it is it's bitwise operation. If it is 4-bit operation, then it is 4-bit microcontroller. If it is 8-bit operation, then it is 8-bit microcontroller. 8-bit operation or 4-bit operation means it will perform 8-bit at a time in its ALU. Then second type is depending upon memory blocks available in the microcontroller. Either it is external memory or embedded memory. In external memory blocks, the memory blocks are not available on the microcontroller, whereas in the embedded memory block controller, the memory blocks are available on the same chip. In external memory block controller, the memory blocks are attached or interface with the controller externally, and to access it we have to use external access signal. Third category is instruction set. There are 2 type of instruction set. One is CISC and other one is RISC. In CISC controller, there are large instructions which will reduce the code size, while in the RISC computer there are small instruction where the code size is larger, but it will reduce the hardware part in the circuits. Fourth type is architecture type. There are 2 types of architecture. One is Harvard architecture and another one is von Neumann architecture. In Harvard architecture, the program memory space and data memory space are available on different. Program memory space and data memory space are different, while in von Neumann architecture, program and data memory spaces are available on the same chip. Fifth one is the depending upon manufacturers. There are various manufacturers available in market for microcontrollers. Either it is Atmel, Atmega, then Intel, AMD. These are depending upon the manufacturers. Now we will start with the various registers available in the microcontrollers. Okay. In microcontroller 8051, in case of microcontroller 8051, there are some general purpose registers, some program counters, stack pointers and some timer control registers are there. In general purpose register, there are 2 registers. One is accumulator other is register B, and third one is register R0 to R7, wherein accumulator is a 8-bit accumulator and register B are 8-bit register, which is used for the arithmetic logical operation purpose. Whenever microcontroller perform any arithmetic or logical function, it will take its first number always from accumulator, and other numbers are taken from other general purpose registers like register B, register R0 to register R7. We use register B while multiplication or division instruction. When microcontroller perform any multiplication or division instruction, it will always take first number from accumulator and second number from register B. And for other operation, microcontroller use register R0 to R7, that are general purpose register. Apart from these general purpose register, there are other registers like register banks. Register bank in microcontroller, there are 4 register banks. These are register bank RB0, RB1, RB2 and RB3. Each register bank contain 8 register in it. Means suppose if we consider register bank 0, then in register bank 0 there are 8 register ranging from R0 to R7. Same for register bank 1, register bank 2 and register bank 3. Then microcontroller have other registers like program counter, that is PC. The function of program counter is when microcontroller performing any instructions, then for performing particular instruction it will always fetch opcode of particular instruction through program counter, and after fetching the opcode fetch, after fetching the opcode of particular instruction, the program counter is auto incremented and it will fetch the next instruction code in advance. Other one is stack pointer. Stack pointer is generally used when it is operation like call operation, where push and pop instructions are used. What these instructions do, when we perform some stack related operation, push instruction will store the previous memory address in the stack pointer, and after returning from the main sub program, when return instruction is executed, the pop instruction will fetch that previously stored last location address into program counter. Then there is one more register called as program status word. Okay, program status word is as name indicated, status word register. It will indicate the status of arithmetic operation it will perform. There are multiple status like carry, auxiliary carry, overflow, parity. These are main 4 status blocks. Then in status block register, it is a 8-bit register. In this 8-bit register, there are 4 status registers and 2 registers are used for selecting register bank, which is register bank 0 to register bank 3, and 2 registers are unused, one for user to use in future applications. Okay, we will see the structure of program status word register. Program status word register is a 8-bit register containing carry flag, auxiliary carry flag, then user defined flag, then RS1 is registers bank select flag 1, register bank select flag 0, then this is kept blank purposefully, and last one is parity flag. We will see all flags one by one. Okay, the function of carry flag is when a microcontroller perform any arithmetic or logical operation, then if we add two 8-bit numbers like 1010 1001, this is one number, and another one is 000010. If we add these two numbers, then what will happen? Its particular status are changed, like auxiliary carry or parity or carry status. If we add these two binary numbers, then it will give us 110 1011 1 plus 1 0 and carry is 1. When we perform this operation, what will happen? The status of carry flag is changed from 0 to 1, means it is set to 1, because carry is generated from 8-bit operation. This one is last 8-bit operation generates one carry, that's why carry flag status is changed. And in case of auxiliary carry, in auxiliary carry what will happen? After adding 4 nibbles, 4 bits LSB bits, if we add 4 LSB bits and if there is carry, then auxiliary carry flag status is changed. Then it is for future application, it is kept for end user. Then RS1 and RS0. RS1 and RS0 are used for. Okay, now we will start with program status word register, that is PSW. As name indicated, PSW stands for program status word registers. It will indicate the status of arithmetic and logical operations. Okay, arithmetic and logical operation. When we perform any arithmetic or logical operation, it will change the status according to result. Either it is parity, carry, auxiliary carry or overflow. As indicated here, it is the format for program status word register. It contains carry flag, auxiliary carry, one is user defined flag, another one is RS1 and RS0. It is used for selecting particular register banks, then overflow flag and parity flag. Okay, we will go with carry flag. What will do with carry flag? The carry flag will change its status when it will perform any two 8-bit number operation, arithmetic operation, then it will change its status. If carry is generated, then carry flag status is changed. Let's consider one example for checking the status of carry flag. 1010 1000 1101 1000. We consider these two 8-bit numbers. Let's find how other flags will affected because of these two 8-bit arithmetic operation. 0 plus 0 is 0, 0 plus 0 is 0, 0, 1 plus 1 is 0, carry 1, then 0 plus 1 is 1, 1 plus 1 is 0, carry 1, 1 plus 0 is 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, 0 plus 1 is 1, but here we get carry bit 1. When we perform the arithmetic operation on these two numbers, what will change? It will change carry flag. It will generate one carry bit after 8-bit operation. Also one auxiliary carry flag status also is changes when we perform 4 nibbles of each number added, then after adding d4th bit of each nibble, it will generate one carry, which will change the status of auxiliary carry flag. It will change status of auxiliary carry flag means carry flag. If carry flag is carry is generated, then carry flag and auxiliary carry flag status is changed from 0 to 1. Then there is one overflow flag and one parity flag. What will happen in overflow flag? is when we perform any sign number addition, subtraction or arithmetic operation of sign number, if the result is exceed than 8 more than 8 bit, then overflow flag will change its status from 0 to 1. And in case of parity flag, if we considering this example, when we perform addition of these two 8-bit numbers, then their result will contain some number as 1 and some number as zeros. If we count number of ones, then there is two number of ones, this one and this one, means there is even number of ones. And if the number of ones in result is even, then parity flag status will change from 0 to 1. And if the number of ones in result is odd, that is in the count of 1, 3, 5, 7, then it is odd parity, and the parity flag status is changes from 1 to 0 and vice versa. Then there is two more bits are there in program status word register. One is RS1 and another one is RS0. What will these two bits do? RS1 and RS0 bits are used for selecting particular register bank. As we discussed earlier, there are 4 register banks: RB0, RB1, RB2 and RB3. By default, if we select register R0 to R7, then default register bank is RB0. Means if we in program write any register from R0 to R7, it is from register bank 0 only. But if we wish to select register from register bank 1, 2 or 3, then we have to change the status of these program status word register bits, that is RS1 and RS0. If the status of RS1 and RS0 is 0 0, then register bank 1 bank 0 is selected. If status of RS1 and RS0 is 0 1, then register bank 1 is selected. If status is 1 0, then register bank 2 is selected, and if status is 1 1, then register bank 3 is selected. This is how we will select the particular register bank for its application. Now in 8051, to access these registers, there is some particular address is there for every registers, and to access these register by their address, we have some address lines and some data lines. In 8051 there are 8 data lines and 16 address lines, out of which lower 8 data lines and address lines are multiplex, means A0, AD0 to AD7 are lower address lines, and A8 to A16 are higher address lines. Where A8 to A16, these higher address lines are particularly used for address purpose only, whereas AD0 to AD7 address lines are multiplex, means it have both function like address as well as data. For selecting it as a address line or data line, we have one more pin, that is ALE. What is the function of ALE? ALE stands for address latch enable. Okay, when we send active high signal on address latch enable pin, then it will send address only, means if we send any data on AD0 to AD7 pin, then it is address only if ALE status is 1. If ALE status is 0, then it will select as a data lines, means if ALE signal is high, then AD0 to AD7 pins are used as a address line, and if ALE status is low, then AD0 to AD7 pins are used as data pins. This is all about this session. In next session, we will continue with architecture of 8051. Thank you students. Thank you all.